and very teeny tasks as well. So let me just guide you through this little section of starting probability. And again, there's not a lot of new stuff compared to year 8, but there are bits of new stuff which, if I've got time, I will do. I mean, outside the scope of this current book, like tree diagrams, which are fantastic year 11 bits of kit. So you can estimate probability by doing some experiments. I think we've thrown dice around the room before, and you can call this estimated probability an experimental probability, but the proper word is a relative frequency. Because if you do an experiment involving dice, and if you throw it, say, 100 times, and you get 15 sixes come up, I bet if you throw it another 100 times, you won't get exactly 15 sixes. So every time you do a cycle like that, an experiment, you can expect different outcomes. But they should really confirm the theory that the probability of actually getting a 6 is 1 out of 6 if it's a completely fair die. Yeah, so I think that's what they're chatting about here. So dice is rolled 100 times, and the results are in there. Estimate the probability of getting a 4. Well, I've thrown a 4 23 times out of 100. So 23 over 100, 0.23, or 23%. Quite straightforward, isn't it? Would that dice appear biased to you? Well, it says biased. How many 4s would you expect, actually? Well, 1 out of 6, a sixth of 100 is roughly 17. So really, if it's a perfectly fair dice, you'd expect 17 of each of these. That roughly comes to 100. So you could say it probably looks biased because I've got far too many 3s, far too few 6s, according to the theoretical expected outcome. But there you go. And that's what just exercise 1 is about. 3 very simple questions. And, hello, Abraham. Well, he's already done this anyway, but I did invite him to the lesson in any case. So Abigail's going to roll a dice, and she's going to find out how many times each number gets landed on. So she's going to throw this. I'm not sure how many that is. I'm hoping it's 100. I don't know. I would assume it's 100. What does that come to? 40, 50, 60, 70, 80, 90, 100. No, it's over 100. 110, 119, 124. I think it's 130. But anyway, I'll let you work that out yourselves. Estimate the probability of rolling each number. Well, the chance of getting a 1 as an estimate is 26 out of 130. It does say simplify it. I know, Ibrahim, you're here now. And I said, you don't need to simplify at GCSE. No, seriously, at GCSE, you never have to simplify any outcomes when it comes to any probability problem, right? You don't do it. So 26 out of 130. What's the probability of getting a 2 by experiment, by relative frequency? Well, that's 21 out of 130. So what I'm doing now is just talking you through this very simple task. And again, I'll post the video, but pay good attention now. Don't wait for the video, just start. It's really, really quick. And as for Ibrahim, like I said, he's done it. He didn't need no video to do this, he just did it. Now, Ben and Dave each tossed the same coin, which is actually a fair experiment, you know. The fact that they're both using the same coin is great, because if the coins were slightly different, then you can argue, well, that's not a fair experiment at all, because that one could be slightly more biased than that one. That could have a little chip in it, a cut in it, that helps it to weigh more to one side than the other. It's the same coin. And these are their results. Find the relative frequencies of the coin landing on the head for each person. What's the chance, using Ben's trials, what's the chance of Ben throwing a head actually using this experiment? Just look at the figures there. Somebody want to unmic themselves and contribute? What's the probability of Ben throwing a head from his experiment?
6 over 20.
Yeah, that's right. No. Don't go into year 5 work now. It's 6 over 20. Don't call it unlikely. Just it wants a relative frequency. If you look up here, there's no words like unlikely, likely, impossible, certain.
Yeah.
These are proper, honest probabilities. Yeah. So here we go. It's 6 over 20. What about Dave?
14. Oh, Dave for heads, did you say?
Yeah, always. There's questions about heads. Yeah.
47 over 100.
Yeah, I agree. And the whole point is not just doing that bit. The whole point is part B. The relative frequencies are estimates of the probability of tossing a head. Whose estimate is more reliable and why?
Dave, because he did it 100 times.
Nearly. Dave, because he used more trials. Or you can say Dave, because he threw the coin 100 times, whereas Ben only 20 times. So yeah, don't say 100.
Yeah.
You've got to compare it with Ben directly, or just say Ben conducted more trials, so it's more reliable. Remember, every time you flick that coin, it's a chance. You may get more heads than tails, or vice versa. That's the nature of an experiment. And if you repeat it, I promise you it'll be different again. But you should expect for a fair coin to get half the number of heads and half the number of tails each time, and the experiment should confirm that. All right, so that's all we need to do. Revise how to work out a relative frequency, which is an experimental probability. We've done question 1 and 2 virtually, and question 3 claims to be extensiony. Not really, it's not. Just 3 questions. If you look on Show My Homework, I said exercise 1, do question 1, 2 and 3. Can I ask please that you actually do copy out these tables, because without that you just have a little list of fractions, which you don't have to simplify, to be fair. It's just don't bother with, even though they said it. Okay, Ibrahim, you did the right thing, man, don't worry. But you don't for GCSE. So do question 1, 2 and 3.